Good day everyone, my name is Jazil Azniel bin Johari and today I will presenting my individual project entitled LM35 Temperature Sensor Simulator using Python Tkinter. This project demonstrated how the LM35 temperature sensor works by using a software-based simulation instead of real hardware. Introduction. The LM35 is a commonly used temperature sensor that produces an output voltage directly proportional to the temperature in degrees Celsius. It is widely applied in real-life systems such as temperature monitoring, industrial automation, and electronic devices. For this project, instead of using a physical LM35 sensor, I developed a simulation using Python to better understand the sensor behavior and the relationship between voltage and temperature. Project objective. The objective of this individual project are listed by two. First, to understand the working principle of the LM35 temperature sensor, and second, to apply basic Python programming concept including input and output, conditional statement, function, object-oriented programming, and all of this to design a simple graphical user interface GUI using Python Tkinter. System overview. This simulator is developed using Python Tkinter, which is a built-in library for creating graphical user interface GUI. The system operates as follows. First, the user input the sensor output voltage in volt. Second, the program convert the voltage into temperature. Third, the calculate temperature is displayed on the screen. And lastly, the system shows the temperature status, either normal or high. All the program logic and GUI components are organized inside a single class, following the object-oriented programming approach. And we are going to another chapter, temperature calculation. The LM35 temperature sensor produces an output voltage that is directly proportional to the temperature in degrees Celsius. Specifically, the sensor outputs 10 millivolts for every 1 degree Celsius increase in temperature. Based on this characteristic, the temperature can be calculated by multiplying the output voltage by 100. For example, when the sensor output voltage is 0.30 volts, the calculated temperature is 30 degrees Celsius. Similarly, an output voltage of 0.45 volts corresponds to a temperature of 45 degrees Celsius. This simple linear relationship allows the simulator to accurately represent the behavior of the LM35 sensor and makes the temperature calculation straightforward and reliable. Program feature. This simulator includes several important features. First, input validation is implemented. If the user enter a negative value or a non-numeric input, the system will display an error message. Second, conditional statements are used to classify the temperature. If the temperature is below 40 Celsius, it is considered a normal temperature. If the temperature is 40 Celsius or higher, it is classified as high temperature. Third, the graphical interface uses custom colors and fonts, making the application more user-friendly and visually appealing. Graphical User Interface GUI. The graphical user interface is designed to be simple and easy to understand. It includes a voltage input field, a calculation button, a temperature display, a status indicator. This design makes the simulator suitable for learning and demonstration purpose. In conclusion, this individual project successfully simulate the LM35 temperature sensor using Python Tkinter. It helps in understanding how sensor voltage is converted into temperature while also strengthening my understanding of Python programming and GUI development. And for future improvement, this simulator can be enhanced by adding a slider instead of manual voltage input, displaying a temperature graph, integrating with real sensor using hardware such as Arduino. That's conclude my presentation. Thank you for watching. Thank you.